For what feels like forever, when we've talked about AI, we've pictured these enormous, powerful data centers in the cloud, right? But a quiet revolution is taking place, and it's not happening in some far-off server farm. It's happening right here, in the palm of your hand.
I mean, we've all been there, right? You're using an AI tool and you get that lag. Or you see another subscription fee pop up. And there's always that little voice in the back of your head asking, where's my data actually going? Well, that's the reality of cloud AI. But what if the smartest AI wasn't out there somewhere, but right here with you, totally offline, instant, and completely private? That's what we're talking about with local AI. And believe me, this isn't science fiction anymore.
So, to really get why this shift is such a big deal, we need to talk about the problems with the way things have been. It turns out the cloud-first model has some serious limitations, a ceiling that we've been bumping our heads against for a while now.
Okay, it basically boils down to three big headaches. First up is latency. Every single time you ask a cloud AI for something, your request has to travel all the way to a server, get processed, and then travel all the way back. That little trip, that's what causes those 1 to 3 second delays that just make everything feel clunky and broken. Then, of course, there's the cost. These services are often subscription or token-based, so the more you use them, the more you pay. Simple as that. And finally, the really big one, privacy. By its very nature, cloud AI means you have to send your data to someone else's computer, and that just opens up a huge can of worms when it comes to security and privacy. So, okay, we've hit this ceiling with the cloud. The solution, then, has to be local. But that brings up a massive engineering challenge, right? How on earth do you take an AI model that was built to run in a giant data center and somehow squeeze it onto a device that fits in your pocket?
Yeah, let's get really specific here to see how crazy this sounds. A pretty powerful AI, say a 7 billion parameter model, takes up about 14 gigabytes of space. Now, think about your phone. It might have, what, 8 gigabytes of RAM? And that RAM has to be shared with the operating system, your other apps, everything. The math just doesn't add up. It seems absolutely impossible.
And no, I'm not pulling that 14 gigabyte number out of thin air. That's the standard size for these models when they use what's called 16-bit precision for their weights. And those weights are basically the building blocks of the AI's entire intelligence.
So here's the first part of the magic trick. It's a really clever technique called quantization. The best way to think about it is like shrinking a super high-resolution photo. You know how you can make the file size smaller without really noticing a difference in the picture? It's the same idea. You're reducing the numerical precision, but the essential details, the core intelligence of the model, are still there. You're not making it dumber, you're just making it, well, more efficient. And the result of this? It is absolutely staggering. You take that 16-bit precision and you dial it down to just 4-bit, and that massive 14 gigabyte model, it shrinks all the way down to about 3.5 gigabytes. That is a 75% reduction. All of a sudden, what looked completely impossible now seems totally doable.
Now, it's important to know this isn't just some crude brute force compression. There are incredibly smart algorithms at play, with names like AWQ that intelligently figure out which parts of the AI's brain can be shrunk down the most without hurting performance, and then special formats like GGUF package everything up super efficiently. The bottom line is, this whole process is designed to make sure the model stays just as smart, even though it's gotten a whole lot smaller.
Okay, so shrinking the model down is a huge first step, but that's only half the battle. You still need an engine that's powerful enough and efficient enough to actually run it. And the amazing part is, that engine is already sitting inside the phone you own right now.
And this really flips the whole idea on its head. We're not talking about running some light or tiny version of an AI. The goal here is to run a genuinely powerful AI, but to do it on a piece of hardware that's become incredibly efficient and specialized. You see, the processor in your phone isn't just one single brain. It's more like a team of specialists working together. You've got the CPU for all the general stuff, the GPU for graphics, but the real hero for our story is the NPU, the neural processing unit. This is a piece of silicon that was literally built from the ground up to do one thing really, really well: the exact kind of math that makes AI work.
So when you put all of these pieces together, the whole process becomes incredibly simple and self-contained. Your request gets processed, turned into tokens, and then handed straight to that NPU. The NPU crunches through the model, and boom, you get your output. But look closely at that process. What's the one thing that's missing? There's no call out to the internet. It never leaves your phone.
Okay, so we've gotten a little deep into the how of it all, but what does this actually feel like when you use it? This is where all that cool engineering turns into a real experience.
I want you to imagine this for a second. An AI assistant that responds the very instant you finish speaking, no delay. An AI that works perfectly when you're on a plane or deep underground in a subway, anywhere you have zero connection. And maybe most importantly, an AI you can trust with your most sensitive information, because you know for a fact it is never, ever leaving your device.
And that right there is the core promise. This isn't just some clever marketing slogan, it is a fundamental architectural fact of how this technology works. If the processing happens on your device, your data stays on your device. End of story.
This simple fact completely unlocks a new world of possibilities. We're talking about a personal assistant that's actually personal because it's always with you, always offline. Real-time language translation where your private conversations stay private. The ability to analyze sensitive legal or medical documents securely, right on your own phone. The potential here is just huge.
So really, what we're witnessing isn't just some cool niche technology. It's the very beginning of a fundamental shift in how we think about, build, and interact with artificial intelligence. You know, for years, the big race in AI was all about who could build the absolute biggest, most massive model in the cloud. But that's changing. Now there's a new race. Who can create these smaller, smarter, hyper-efficient models that are built from the ground up to live on the devices we carry with us every single day?
And believe it or not, the next step is even more exciting. There are new techniques coming out, like something called LoRa, that will allow these on-device AIs to actually learn and adapt based on how you use them. It can learn your style, your preferences, and become a truly personalized companion, all while keeping your data 100% private. It's personalization without compromise.
So all of this leaves us with a really fascinating question. As we look to the future, what's going to define the next chapter of AI? Is it going to be about even bigger clouds and more massive data centers? Or is it going to be about smarter devices with decentralized, private, and hyper-efficient intelligence living right alongside us? If you ask me, it seems like the answer's already in your pocket.